Okay, first we're going to look back and review how to add and subtract fractions. For instance, if we have 1/2 minus 3/4, I know you guys are typically like, oh, I'll just type it in my calculator and I'll get -1/4. Because we're going to be dealing with variables, that is no longer an option. So let's go back to the basics of adding and subtracting fractions. So 1/2 minus 3/4, well, we cannot subtract those because they don't have like denominators. So we have to rewrite the expression so it has, or rewrite the fraction so it has a like denominator. So since 3/4 and 4 and 2 share a common factor of 4, or a common multiple, sorry, of 4, we need to make the denominator of the first fraction 4. So I have to do 2 times 2 to get 4, but to be mathematically correct, I have to multiply both the numerator and the denominator by 2. So 1 times 2 is 2, 2 times 2 is 4, 2/4. Okay, so really that fraction is 2/4 minus 3/4. Now that my denominator is the same, I can just subtract my numerators. So 2 minus 3 is -1, so -1/4. Okay, and then we go to, let's look at our second example of 1/3 plus 3/4. 3 and 4, neither of those, or we have to find the common multiple that both of those go into. It happens to be 12. So I have to multiply 3 by 4 to get that. So 1 times 4 is 4, 3 times 4 is 12, so we have 4/12. And I have to multiply 4 by 3 to get 12. So 3 times 3 is 9, 4 times 3 is 12. So we have 4/12 plus 9/12, which is 13/12. So that's just a quick recap. But remember, to add and subtract fractions, you need to get a common denominator. Then you add or subtract the numerator and leave the denominator alone. We're going to practice this with rational expressions, aka fractions with a bunch of variables. Okay, here's kind of the 6 steps you want to follow when you add rational expressions. Go ahead, pause the video, and write those down. You're going to want to use those in class tomorrow. Okay, let's use those 6 steps we just wrote down and add rational expressions here. So first thing that we wrote down was factor. So we have to factor our expressions. Now I forgot to write the problem on the top of the page. So what we're going to be doing is 1 divided by x squared minus 4x minus 12 plus 3x over 4x plus 8. What I mean by factor is we have to factor everything. In this case, all we can really factor is our denominators. So this factors to x minus 6 and x plus 2. And then the fraction on the right, all we can do there is factor out the 4, leaving us with 4x plus 2. Then if we can simplify, we should. Notice here, we can't cross simplify with addition. We can only simplify vertically. So with this 1, x minus 6, x plus 2, there's no common factor, so I can't cancel anything out. Same here. Now if this 3 happened to be a 2, 2x over 4, x plus 2, that 2 and the 4 could reduce. Obviously it's not, so we're not going to do that. The second step, so that was simplify. The third step is to find a common denominator, which for some reason I can't see on my screen right now, but hopefully I'll fix that when I actually finalize this video. Third step is find the common denominator. So what you have to do is you look at your fractions, and I have an x minus 6, x plus 2, 4, x plus 2. Notice so your common denominator has to include all of the pieces of your denominator. So we have an x minus 6, x plus 2, x plus 2, and 4. So my common denominator is going to be 4. Actually, it's up here on the right-hand side of the page. 4, x plus 2, x minus 6. This x minus 6, this x plus 2, and this 4. This x plus 2 is in both of them, so we don't need to write it twice. So what we have to do then is multiply each fraction to make that common, so they all have they share the common denominator. So I multiply the first fraction by 4, the second fraction by x minus 6, giving me this. The fifth step is then to add our fractions. So 4 plus 3x squared minus 18x is 3x squared minus 18x plus 4, all over my common denominator of 4x minus 6x plus 2. And then the last step, again, is simplify if possible. So in that case, we would have to actually factor the numerator, which in this case we can't. And if in the numerator, if it had common factors with the denominator, we could cancel them out. That will be a very rare case, but it is a possibility. So I did want to make sure I addressed it with you guys. Here are our 6 steps in subtracting rational expressions. Again, pause the video and go ahead and copy those down. because you'll use them in our next example and all throughout class tomorrow. Okay, so here's our subtracting rational expressions example. Here's the problem: x over 3x squared minus 9x plus 6 minus 2x plus 1 divided by 3x squared plus 3x minus 6. Again, our first step is factor everything. All I can factor is my denominators. This first one, we can factor a 3 out, and then we'd be left with x squared minus 3x plus 2, and that x squared minus 3x plus 2 can factor further to x minus 2, x minus 1. So that's how I get this first fraction, x divided by 3, x minus 2, x minus 1. And I'm going to take that fraction, I'm going to subtract it with this fraction. So 2x plus 1 divided by 3x plus 2, x minus 1. How did I get that? If you factor the 3x squared plus 3x minus 6, you can factor 3 out, and you'd be left with x squared plus x minus 2, which factors to 3x plus 2, x minus 1. So once you do that, the second step is simplify. Again, we can only do that vertically. There's absolutely nothing we can eliminate because there are no identical factors here. So the third step is find your common denominator, which again has to include every piece of our denominator. So we have a 3, x minus 2, x minus 1. Look at our other fraction. The only thing that we don't have that's in the first fraction is the x plus 2. So our common denominator is 3x minus 1. 3x minus 2, x minus 1, and x plus 2. So all 4 of those pieces is our common denominator. So then fourth step is multiply. So to make the common denominator the same, I have to multiply this first fraction by x plus 2 and this second fraction here by x minus 2. So I do that. X times x plus 2 is x squared plus 2x. And then here 2x plus 1 times x minus 2 is 2x squared minus 2x plus 1x, so minus 3x. And then 1 times negative 2 is negative 2. And then fifth step is subtract. So we're going to subtract those since now they have common denominators. X squared minus 2x squared is negative 1x squared. 2x minus a negative 3x is really 2x plus a positive 3x, so 5x. And then 0 minus a negative 2 is really 0 plus 2. So we have a positive 2 there. So we have negative x squared plus 5x plus 2 divided by 3, x minus 2, x plus 1, x plus 2. Again, sixth step here is simplify. I cannot factor that numerator. The only thing I technically could do is factor out a negative 1, which you could. I wouldn't mark it wrong if you did, but then that would be our final answer. Here's your list of how to simplify complex fractions. So go ahead, copy that down, pause the video if you need to, because again, you'll want it written down for our next example and for what we're going to do in class tomorrow. Here's our complex fractions example. Here's our complex fraction. We have 3 divided by x minus 2 minus 5 all over 2 minus 4 divided by x minus 2. So fractions within fractions, hence complex fractions. Our first step here, like the list said, is to set up a division of two expressions. So I don't like the way this looks, and I think it might be easier if we write it as 3 over x minus 2 minus 5 divided by 2 minus 4 divided by x minus 2. Okay, so we have those two expressions that we are dividing. Second step is to add or subtract first expression and second. So we have to take what we learned in the first two examples here and add and subtract the first expression, so the numerator, and the second expression, the denominator. So I look at just my numerator, 3 over x minus 2 and minus 5. The common denominator there is x minus 2. So I have to multiply this negative 5 times x minus 2, or this negative 5 over 1 by x minus 2. So doing that, I'll have 3 over x minus 2 minus 5 times x is 5x, 5 times negative 2 is negative 10, all over x minus 2. I have to do the same with my second fraction here, or my denominator, my second expression. So 2 minus 4 over x minus 2, again, common denominator is x minus 2. So I have to multiply the first fraction by x minus 2. So we get 2x minus 4 over x minus 2 minus 4 over x minus 2. So now that I have common denominators, I can, in this case, subtract them. So 3 minus 5x minus 10 is going to be negative 5x plus 13. And then 2x minus 4 minus 4 is going to be 2x minus 8. So we have negative 5x plus 13 over x minus 2 divided by 2x minus 8 over x minus 2. So the third step is going to be now switch it to multiplication. So this second fraction gets flipped. And fourth step is to multiply the expressions. The nice thing here, the x minus 2's will cancel. So really our expression is just negative 5x plus 13 divided by 2x minus 8. And then fifth step, again, is simplify if possible. This could be a great final answer. You could technically factor out a 2 from the denominator, but because neither of the terms in the numerator are divisible by 2, or since both of them aren't divisible by 2, it's really irrelevant because we can't divide either of them by 2. Make sure, I know this is a very complex, hence the name of the example here. I know this is a very complex lesson. We are already terrified of fractions, so this makes it even worse. But don't hesitate to write all of the questions down you have, and I'll gladly take the time to explain it to you in class and go through it. Thank you. Have a nice night.